Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on signal to noise ratio. Okay, so earlier on, I have discussed why signal to noise ratio is so important, okay, to determine whether we can or we cannot receive the signal. So basically, one of the essential so-called items that affect the signal to noise ratio is actually the noise in communication system. So this video, we are going to take a close look, okay, on both external and also internal noise. I will identify the different noise and what are their role, okay, so as to reduce the noise as much as possible. So basically, this will be the objective of this video is to identify the external and also the internal noise. Guys, if you're keen to know more about signal to noise ratio, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on signal to noise ratio. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or not. If you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand what is actually noise. In communication system, noise actually refers to any unwanted or random signal that interferes with the desired signal, potentially degrade the quality and also the reliability of communication. Okay, so again, let me use the classroom. Okay, so for example, the desired signal is actually your teacher that actually deliver a class. So that is actually the desired signal that you actually want to receive. However, okay, let's say your classmate is making a lot of noise. Okay, this can become a interference. So this is actually what they mentioned over here. So therefore, noise can actually originate from various sources, okay, both internal, okay, which is within the system, and also the external, which is outside the system. Okay, so this one we will take a close look. Okay, what is actually internal and also external noise? In practice, the addition of noise to the information carrying signal is actually unavoidable. And therefore, this interference we need to degrade. Okay, basically, they will degrade the quality of the transmit signal. Due to the reduction in the signal to noise ratio, the receiver actually struggle to decode the transmit signal accurately. Okay, this ultimately reduce the system efficient. Okay, so over here you can see that because of noise, both internal and also external noise, okay, they actually reduce the signal to noise ratio, which make difficult for the receiver to decode the message effectively. Let's come to the source of noise. So earlier on, I did mention that there are actually either external source or internal source. Let's take a look on this diagram here. Okay, you can see that this is actually a device. Okay, so all the noise that is within the device, we call this internal noise. Anything that is outside the device, we call this external noise. Okay, so external noise is actually disturbance from outside the communication system, okay, which is the device, okay, such as atmosphere noise, galactic noise, or interference from other device. As you can see here, so we have external noise that actually add into the device. We also have the internal noise. So basically, this kind of noise they actually generate within the system itself. They include the thermal noise, shock noise, flicker noise, and also the noise due to electronics component, okay, which we are going to take a close look. Okay, so basically from here you can see that noise can be classified into two types, external or internal noise. Okay, let's come to the internal noise first. So most important noise is actually the thermal noise. Okay, so this is actually the dominant noise, okay, under this internal noise. Okay, so this thermal noise is also known as Johnson noise or white noise. Okay, so it arises from the random movement of electrons in conductors. When electrons actually collide with each other, they actually generate vibration. Okay, this actually led to random fluctuation in voltage and also current. Okay, so this noise is proportional to both the temperature and also the bandwidth of the system. Okay, so what does this mean? Okay, so for example, you can imagine this electron when the temperature actually higher, okay, they actually got more energy, they vibrate more, and therefore because of this, you are going to have higher so-called fluctuation in terms of the voltage or current. Okay, so why they are called white noise? Okay, so this is what you mean here. So thermal noise is also approximately called white, okay, which means that the power spectrum density is nearly equal throughout the frequency spectrum. Okay, which means that no high frequency, no low frequency, they are almost the same throughout the whole frequency spectrum. Okay, so the thermal noise, basically they are unavoidable and they are caused by thermal vibration, okay, between free electrons and also vibration ions in a conductor. Okay, so this is actually the equation to calculate the thermal noise. On my next video, okay, I will have some example, okay, to show it to you how can we actually calculate the thermal noise. But this video, I just want to concentrate to identify the different types of external and also internal noise. Okay, I come to this on my next video on the calculation portion. So next, we have the short noise. Okay, so this short noise actually occurs in semiconductor device, especially diode and transistor, okay, due to the discrete nature of charge carrier, okay, electrons and hole. Okay, so if you still remember transistor, you have this so-called separation, okay, between the electrons or hole, okay, which is the potential barrier, and this is why we have this short noise. So in transistor, it arises from the random flow of electrons leading to current fluctuation again. Okay, so over here you can see that because of some changes of electron, because of the movement, because of the vibration, they actually change the current, and therefore because of this, okay, this become a form of internal noise, which is known as short noise. Okay, again, this is the formula to calculate the short noise. Okay, but I will do more explanation on my next video how to calculate the short noise. But over here, you can see that short noise is actually depends on the current, the DC current, and also the bandwidth, which means that when the bandwidth, okay, is large, you actually will have more noise, which makes sense, right? Because imagine the bigger the classroom, you are going to expect more noise. So therefore, it's still the same for bandwidth. The larger the bandwidth, okay, I'm going to expect more so-called more noise. Okay, so the current, okay, will be also the dominant factor of short noise. Next, okay, before I continue, guys, again, if you have learned something from this video, okay, I appreciate that you can help me by like this video. Okay, when more you guys actually help to like this video will have a better chances to reach up to a larger audience. So guys, help me press the like button now. Again, urge you, if you have learned something and if you have not subscribed to this channel, okay, don't hesitate. Help me subscribe to this channel and also turn on your notification bell. Once again, thank you so much for strong support. Another internal noise, which is the flicker noise. Okay, so this is also known as 1 over F. This F is actually frequency noise. Okay, so these types of noise actually exhibit a frequency-dependent characteristics where its power is inverse proportional to frequency, as you can see from here. Okay, so they are mainly dominate at low frequency, okay, below 1 kilohertz. Okay, so it actually diminish as frequency increase. Okay, this arise from various factors such as the fluctuation in the carrier density or mobility in active device. Okay, so basically this is what the definition key idea that you need to know about flicker noise. So they are inverse proportional with frequency, which means that higher the frequency, the less noise on the flicker noise. So they are also directly proportional to the temperature. The higher the temperature, the bigger the flicker noise. So all this you need to be very careful. So this flicker noise, they actually dominate at low frequency, typically below 1 kilohertz. And like I mentioned earlier on, they have inverse proportional relationship with the frequency. Okay, so next, okay, we also have impulse noise and also crosstalk. Okay, so impulse noise actually consists of irregular pulse or spike of short duration and high amplitude, often caused by electrical interference or lightning, as you can see from here. As for crosstalk, basically these are undesired interference from one circuit or channel to another. Okay, so for example, okay, the noise can couple over, okay, from one so-called conductor to another conductor. So basically, these are some of the internal noise that we are going to take a close look on my next video. Some example how to do all this form of calculation, how to calculate the noise. For example, the frequent noise, the short noise, and also the thermal noise. So all this we will take a close look on my next video, how to do a calculation so as to estimate the amount of noise. So therefore, we can actually have an overall signal to noise ratio. And from there, we are able to determine whether we can or we cannot receive the signal. Next will be on the external noise. Okay, so most of the time, I will say that we can't do much on external noise. Okay, so as it mentioned earlier on, external noise basically will be introduced into a system, okay, either by a receiving antenna or by electromagnetic coupling. Okay, so basically the receiving antenna receive the signal, the external noise also will be amplified by the antenna. Okay, if not, they may be also in the result of coupling. Okay, so some source of external RF noise. Okay, so in short, I think the first two are more crucial, which is the thermal noise from the ground and cosmic background noise from the sky. Okay, the rest, okay, like I mentioned earlier on, you almost cannot prevent anything to stop all this external noise. So you can only just minimize the noise. Okay, talking about the impact, okay, let's quickly understand, okay, how does the noise actually impact the quality of a communication system? Okay, so I have done numerous discussion that when the noise actually becomes significant as compared to the signal strength, they actually reduce the signal quality. Okay, so noise actually obstruct the desired signal. Okay, so as I told you in the classroom, when noise is also almost equals to the original signal, this make it very hard to detect the signal and very difficult for us to interpret the signal. Okay, so even for simple so-called face-to-face communication, if the noise is also high, we may not be able to hear and then to interpret the message also. When noise is increased, this also increase the error rate. Okay, because as you know that when you have more noise, okay, you probably have the chances to miss a few bits in a digital communication. So basically, as he mentioned over here, the noise can cause error in data transmission, especially in digital system. Okay, digital system mainly consists of 0 and 1. Okay, so because of noise, okay, it may not become 0 anymore, it become close to 1, let's say. You may have all these so-called issue which in result in error. Next will be the reduced system range. Okay, noise can limit the distance over which the signal can be reliable transmit. Okay, because of noise, okay, just imagine in a classroom. Okay, if the class is very noisy, I can't transmit the signal very far away. Okay, so therefore, because of this, I probably can only transmit a very short distance. So basically, this is the meaning from here. So if the noise become equivalent to the original signal, this potentially limit the range that I actually can send the signal over. Next will be the system sensitivity. Okay, the noise actually affect the sensitivity of receiver. Therefore, they actually limit the ability to detect weak signal. Okay, so again, all this, okay, I think you already understand. Okay, so from here you can see that these are the four impact of noise. Coming to my last slide here, okay, how can we actually reduce the noise? Okay, so this slides here actually discuss the noise reduction techniques. Shield, okay, I think shield, which means that you actually protect the circuit, okay, by putting a conductive material, etc., to prevent coupling, for example, here. So shielding is to protect the circuit and cable from external interference. Okay, so basically you shield your device, so you actually receive less crosstalk, which means that less noise, which means that higher signal to noise ratio. Filtering, okay, so you can consider to use electronics filter, okay, to remove unwanted frequency from the signal. Error correction code, okay, so we can add some redundancy to the data so as to detect and maybe even to do some error correction, okay, that basically introduced by noise. Increasing signal strength, okay, we can boost the signal to make it more robust against noise, which means that we transmit a larger signal. For example, okay, instead of talk gently, I can shout. Okay, so when I actually shout, I actually increase the signal strength. So when I actually shout, the chances to send the message over to the recipient also increase. So basically, this is also another way, okay, in order to combat against noise. Next, okay, we can concentrate how can we actually reduce the noise source so as to minimize the noise generation at the source as much as possible. Okay, with this, I'd like to end my discussion. Okay, please help to like this video and also subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.